All right, let's have a look at some of these. We'll start at the bottom. Yeah, this one had 6 attachments. I know we didn't get to all of them. I don't know if they're in order or which one you want to open. Can you tell by looking at them from your view?
That one's not it.
Okay.
It should be it's probably the other one.
The next one.
That's strangely not it either.
That's okay. I got another one.
Yeah, that's it.
All right. Which attachment? Do you know? Can you tell?
I think it would probably be the third one. No, I'm wrong.
Okay.
They're probably out of order.
All right. Let's just look at each one of them. That starts at 22.
Yeah, we need one that starts at 9.
That starts at 27. Okay. Let's have a look at this one. That starts at 5. And this one starts at 7. So if we're going in order, this looks like the first one.
Yeah, that's on the written response portion. I guess we could start with that, yeah.
Well, you direct. You're always the director here, because only you know where you're having difficulties.
I just am confused, like why not all the pictures sent and why they're so out of order. So.
Well, it looks like we got plenty to keep us busy.
Yeah.
Let's start with this one. This one was this one here. Let me download it. Open it up so that I can zoom on it. Let's have a look at this question.
There's a question above it too, by the way.
Not on this page.
There is. You just can't really see it.
Well, okay. That has to do with this same function, or?
No, it's just on the line above it. I have the paper in front of me.
Okay, can you read it?
Yeah. So it's find the values of the constants a and b for which the function equals sine of x if x is less than pi, and then ax plus b if x is greater than or equal to pi.
So we have a piecewise function, and it's sine x whenever x is less than pi, but it's ax plus b, a straight line, whenever x is greater than or equal to pi.
Mm-hmm.
Okay, and what is the question again?
Find the value of the constants a and b for which the function equals that what I just gave you is differentiable at, oh my gosh, it was covered at pi.
Mm-hmm. If it's differentiable at pi, then it is continuous.
Mm-hmm.
Okay, so let's put pi here. Well, if I draw the sine curve for pi, that's what it looks like. But then they're saying that it is some straight line after that.
Mm-hmm.
With me?
Yep.
And they're saying it is differentiable at pi, which means it's continuous. That's the main important thing. So what do we know is happening at that point in time? regarding these two functions?
They're meeting?
They're equal. Yeah, they're meeting because they're equal. In other words, the sine of pi is equal to ax plus b. And excuse me, equals a pi times b.
Mm-hmm.
Now, the sine of pi is 0. So we have 0 equals a pi plus b. They want both a and b?
I think so.
Well, I guess minus b would be equal to a pi. So minus b over a would be equal to pi. But that's the best I can do because I only have one equation to work with. I don't have two. In other words, I know what the sine of pi is. In other words, I know what the left side is. That's 0. It's going to approach 0. So I know the sine of pi is 0. But I got 0 equals ax plus b. That's one equation, two variables. Even when I know that it's equal to a times pi plus b, I guess I can solve this now that I think about it. Sure. So b, well, hold on. b is equal to minus a pi. That's what b is equal to. And a is equal to minus b divided by pi. Now, I haven't come up with a numerical value for a because there are literally an infinite number of answers for that.
Mm-hmm.
So I'm not sure what's happening, but let's not spend our whole session on this one problem that I can't see the instructions on even.
Okay.
Let's go to the next one. Raise this up a little bit. This looks like an interesting one. Again, we got to be careful spending too much time on the really interesting ones because it's just not the best strategy if you're trying to maximize your grade.
Mm-hmm.
You don't want to spend a half an hour on a problem that you may at best get once on a test.
Yeah.
So, what if I were to ask you, what is h prime of x equal to?
It's just f prime of x.
Hold it.
E.
What's the derivative of the outside first? You really want to start with the derivative of the inside. Not quite sure why. Is that the way your teacher teaches it?
No.
Am I the only one that says derivative of the outside times derivative of the inside?
No, you do it right.
Well, it's not a right or wrong. It can be done either way. And I've postulated before, as I'm not sure why it's done outside times inside. I think when you have multiple insides, it works out easier that way.
Mm-hmm.
What's the derivative of the outside?
E to the f of x.
What's the derivative of the inside? Whoops, didn't mean to put that little
F
there.
F prime of x.
Okay. Now, they tell us that h double prime of x, well, let's figure out what it is. We can do that. the power rule, or it's the product rule, and the chain rule. In other words, we're going to solve for what h double prime of x is, and then we're going to let it equal that thing over there. Then we're going to be able to answer the question, what is f prime of x? I think. I'm sure that that's the way it's going to work out. But let's go ahead and apply the product rule and the chain rule to this. Start with the product rule.
So it would be e f of x times 2x.
Hold on, where are you getting 2x from? Well, you're going up here and looking at that. Let's not look at that for the moment.
I thought we were just doing the product rule.
Well, we are. We're applying it to that. So we're taking e to the f of x, that's u, and then we want to take v prime, which is f double prime of x, and we want to add to it the reverse. Now the reverse is e to the f of x times f prime of x times f prime of x. I believe, in other words, if that's u and that's v, then this is u times v prime plus u prime times v. With me?
Kind of.
Okay, well, all we did was apply the product rule in combination with the chain rule. In other words, we applied the product rule, and then when we had to do e to the f of x, then I had to make that e to the f of x times f prime of x again. The only difference is now, because we were taking the derivative of f prime of x, that's f double prime of x. Now they tell us what h double prime of x is equal to. So down here, I'm going to write what it's equal to. E to the f of x times 1 plus x squared. And that's supposed to equal that whole thing. Well, let's take that whole thing we started with and factor out. What can we factor out from where I'm pointing here with my cursor? From that, what can we factor out?
An f of x.
E to the f of x. In other words, that is e to the f of x times f double prime of x plus f prime of x times f prime of x. So that's what I get when I factor out an e to the f of x. Well, now this h double prime of x that I've written down here is equal to that. Notice that the e's to the f of x's cancel from both sides, and I'm left with 1 plus x squared on the left side of the equation equals f double prime of x plus f prime of x times f prime of x. What do you think f prime of x is? Figure it out from just looking at that. What would make that true? This is an unusual equation to solve. We almost never have to do this. This is, in fact, one of the few types of equations I've seen like this. Let's experiment. What if f prime of x were x? In other words, that's my hypothesis. F prime of x is going to equal x. Now, what would this bottom line be? In other words, what would that equal if that were true?
Would it be x squared?
Be 1 plus x squared. In other words, f double prime of x is going to be 1. And f prime of x, that's also x. X times x is x squared. So if f prime of x were equal to x, h double prime of x would equal 1 plus x squared. Again, a problem way more difficult than you're ever going to get on even the AP Calc exam. You're just not going to get something this tough on the AP Calc exam. I've seen enough AP Calc exam questions, and this is extremely tough. So let's not spend any more time on this. But that's how you basically do it, is you just start solving for h prime of x, then h double prime of x, and let h double prime of x equal that and see what happens. And good things did happen. All right, let's look more. These are more of the problems. You're going to have these kind of problems on the AP exam for sure. Implicit differentiation. So there's our function. Implicitly differentiate it for me.
Okay.
We're doing A.
Okay, so it would be 3x squared.
Oh, hold on, let me write this part. dy dx is equal to 3x squared.
Don't you not want to make
Hold on. I made a mistake there.
Yeah.
We don't want to write that there. This is implicit differentiation. We're going to implicitly differentiate it and end up with our dy dx inside the equation. Okay, what else?
And then it would be minus x dy dx.
Important that you add those parentheses.
Okay.
Y. What's the rest of it?
Times.
No. Plus product rule.
Oh yeah. Plus. Just 1.
Y. 1y.
Yeah, 1y.
Second part of the product rule, you're taking the derivative of x times y. Well, that's just y. We're not differentiating y, so we don't have to add another dy dx.
Yeah.
Now do you see why the parentheses are so needed?
Yeah.
I am subtracting that thing. And what I circled at the top is what is in the parentheses. In other words, if I don't put parentheses, I'm getting the sign wrong on that y. Okay? Now, what's the rest of it?
Plus 2y dy dx.
All equals what?
0.
Okay, next step.
Subtract 3x.
I'd be inclined to make the next step, let's get rid of those parentheses. Always, I like to get rid of parentheses.
So would you just multiply -1 through that, so it'd be negative x?
So it doesn't change the first term, but it does change that to a negative sign. So it's minus, what was that? X minus y. All right, so I think that's right at this point. Now, conceptually, what is the next step?
Subtracting 3x squared.
Okay, when I say conceptually, I mean we're going to gather every term that has a dy dx in it, put it on one side of the equation, and put everything else on the other.
Well, yeah, that's exactly what I was doing. So
I know you were. So we're going to end up with this on the left side, and we're going to end up with this on the right side. Now what?
Then you take out dy dx.
Factor out a dy dx.
Yeah.
So in the final analysis, what's dy dx equal to?
Y minus 3x squared over negative x plus 2y.
Okay, I might be inclined to write it like that, merely to keep my y's and x's in the same order. It may enlighten me. It may show me a way that I could factor something out.
Okay.
It doesn't. In other words, I believe that's the final answer. I don't see how you can simplify it at all. That's the way you do implicit differentiation. Now, for B, let me erase some of this stuff. I don't think I need any of this anymore. So all I need is what the derivative was. Okay. So B, find all points on the curve whose x-coordinate is 1 and write an equation for the tangent line at each of these points.
I don't know how to do that.
Well, I'm not sure I do either. Y minus 3, if I substitute x for 1. Hold on a minute. This is the derivative. Think about this for a second. Find all points on the curve whose x-coordinate is 1. Well, here's the curve, the original curve. And if I substitute 1 minus y plus y squared equals 3, I have a quadratic, correct?
Mm-hmm.
Well, I can solve that quadratic. That becomes y squared minus y minus 2 equals 0. And so that factors, what's it factor into?
Plus 1 minus 2.
Good. So that means y is equal to minus 1 or plus 2. And so there's 2 points on the curve. There's this point where x is equal to 1 and y is equal to minus 1. And there's this point where x is equal to 1 and y is equal to 2. Notice we're not looking at a function. We're looking at a composite function. Or it's not called a function, it's a relation. But we have found the 2 points. By substituting 1 for x in the original function, we found ourselves with a quadratic that could be solved. So whenever x is equal to 1, y has 2 different possibilities, minus 1 and 2.
Mm-hmm.
And now it says, and write an equation for the tangent line at each of those points. Sounds hard, but it really isn't. First point, this one here. What's the slope of the tangent line at that point?
I do not know.
Well, here's our derivative, right?
Would we just plug in the point?
Well, we got two different points. So the first,
Would we just plug in a set of points to find it?
there's two different lines. They're going to have different slopes. Once we get the slope of each line, then we're going to use the point slope equation to come up with the equation of that line. So getting the slope, okay, there's minus 1 for y, minus 3, all divided by minus 2 minus 1. So that is minus 4 over minus 3. So that slope is positive 4/3. Merely plugging in the x and y coordinate into my derivative. Okay. Now we have the slope of that line and we have a point. So what's the equation in point slope format?
The equation in point slope would be 4/3.
Hold on. Remember, it's y minus y1 equals the slope times x minus x1. That's point slope format. So our y point is minus 1, which turns that into that. Our slope is 4/3, and our x point is positive 1. There's the equation of the first tangent line that goes through this point 1 comma minus 1. Let's look at the equation of the second point. What is its slope going to be?
So it would be 2 minus 3 over 4 minus 1.
So that is negative 1/3.
Yeah.
Okay. Now use the same point slope format. There's our point. There's our slope. What's the equation?
It would be y plus.
It's y minus y sub 1.
So it'd be y minus 1.
No. Y minus 2. We're looking at this point now. We're off of that first point. There were 2 points on this function where x was equal to 1. And y had a different value at each one. So my y coordinate, my second point, is 2. My slope is minus 1/3. And my x point is still 1. So there are our 2 different equations of the tangent line at each of those points. Now, again, this is a long problem. I don't know that it's necessarily hard, but it is of the type that would be on the AP Calc exam and all the way, I haven't even looked at the C part yet. Find the x coordinate of each point on the curve where the tangent line is horizontal. Okay, let me erase some of this stuff. What does that mean about our derivative? If the tangent line is horizontal, what is our derivative at those points?
That means it's nothing.
0. Don't say nothing.
Okay.
It's 0. It has a 0 slope, right? Well, That's the slope. So I'm going to solve this equation. There's the derivative. They're asking where is the derivative equal to 0. Now, when you have 0 equals a fraction, there's only one way it's equal to 0, and that is if the numerator is 0. So I can basically erase the denominator and solve that. Find the x-coordinate where the tangent line is horizontal. Well, what do we got here? We got y equals 3x squared. That was the numerator of our derivative. That has to be 0. And there are numerous points, obviously, where that is 0. That's a parabola.
So we just...
A little confused here. Here, I want to do something real quick. I want to bring up... God, that's the only thing I hate about this, taking a screenshot. Y minus 3x squared. Remember that. In fact, here, let me write it down on a piece of paper. Y minus 3x squared has to be equal to 0. What was the entire derivative? Y minus 3x squared over what? I think it was 2 minus y. Was that it?
I think so, yeah.
Oh, God. Well, let's put this into Wolfram Alpha, graph it, and we can visually look and see where the tangent line is horizontal and maybe get a clue as to how to solve this. Now, we always want to graph the original function. Okay, so it's x cubed minus xy plus y squared equals 3. X cubed minus xy plus y squared equals 3. All right. If we look at that curve, we immediately see that it is definitely not a function, does not pass the vertical line test.
Yep.
There are, I see 2 places where the tangent line is horizontal. Right here and right there. No other place. So we have an x value right there and an x value right there that looks like plus or minus 1 are going to be my answers. Let's see, hold on a second. Let me see what else this gives us. This might tell us what the derivative was. No, it's implicit differentiation. Okay, so the bottom was 2y minus x. 2y minus x. In other words, their answer switches the top and bottom. Dy dx is 3x squared minus y, which is the reverse of mine. So I'm making the bottom the reverse of theirs. All right, that was our derivative. So we know if we're solving that for 0, y equals 3x cubed. Well, if x is 1, y is going to be 1. No, but it's not. No, if x is 1, y is going to be 3. And it's not in either case here. Why is this hard to solve? I know what the derivative is. I set it equal to 0. It means y minus 3x squared has to equal 0. And I can tell on this thing, I got something wrong here. I'm not sure what. I don't particularly want to go back and redo the whole problem from the start. It wastes too much time. But here's what I'm seeing. In other words, I'm saying that it sure looks like the answer is minus 1 right there and plus 1. At both of those cases, but in this case, y is a little bit more than 2, and in this case, y is a little bit less than 2. I guess if I plug in, I don't know, I'm a little bit at a loss on how to proceed with this, even looking at a graph.
Yeah, me too.
So let's go on. Integer solutions. There's our 2 points that we came up with, 1 and minus 1 and 1 and 2. And that was where we had what? That's where x was equal to 1.
Yeah.
All right, I'm overlooking something somewhere. Not sure where. But let's get back to doing some of these. Wow. I'm a little astonished and a little bothered by how tough they're making these questions. I mean,
Yeah,
calculus is tough enough without them toughening it up. Now, I know that your school has a habit of toughening up everything. It's like Devlin almost. Devlin toughens up everything, and they do the same with AP Calc. They have 2 courses at Devlin. They have an AP Calc course, and then they have an Honors Calc course below it. You drop
really?
out, yeah, if you drop out of AP Calc, you go into Honors Calc. And if you drop out of that, you go into regular Calc, I guess. But
Oh, they had all those classes.
I didn't know they did either until I was working with a student that find the x-coordinate of each point on the curve where the tangent line is horizontal. Boy, I just don't know how to. I feel like I'm overlooking something by having y minus 3x squared equal to 0. That should give us the answer, but I can't figure out how. I feel like I'm just kind of making a stupid mistake, but nonetheless, let's go on. So I need to close out that. That was that page, and I believe this was where it picks up. Yeah, 7, 8. It's going to be tough for me to read. Here, let me download it first. Now, these kind of questions about particles moving along the x-axis, those are critical. You definitely want to be able to do all 5 parts of this.
Okay, could we go over that one then?
Yeah, let me have a look. We got about 20 minutes. That's probably all the time we'll need. So let's go over number 8. If we have time left over, we'll go back and do 7.
Okay.
Now, when it talks about a particle moving along the x-axis, there's the x-axis. It's talking about a particle that starts somewhere. It moves to the right for a period of time, and then it moves back to the left for a period of time, and then it moves to the right for a period of time. So it could have started there and ended up there. That's called its displacement. But the total distance traveled is the sum of all of those distances that I drew. So there's a difference between displacement and the total distance traveled. Okay, let's look at the equation. The equation is governed by this x of t function, where the distance that it moves is x of t. In other words, at time 0, the particle is at 48, position 48. So that would be labeled 48. And I got that by just plugging in 0 for t. Got minus 2 cubed, which is minus 8, times minus 6. So plus 48 is where it starts out at. All right, let's look at their questions. Find the velocity and acceleration of the particle at any time after t equals 0. Well, velocity is what? What's the definition of velocity?
It's the derivative
Of position. It's the derivative. In this case, it's x prime of t.
Yeah, so it would be.
Let's figure out what that is.
So first we have to do the chain rule, and that would be.
First, you got to do the product rule. Always know that when you have to do the product and the chain rule, do the product rule first. Now, notice what the derivative of both end sides are. They're both 1. So we're really not going to need to do the chain rule. Because all you're going to have to do is just do the product rule. So what's the product rule here?
So it's t minus 2 cubed times 1
Okay.
plus 2, no, I mean, no, 3 at the front, t minus 2 squared, and that's it.
Well, no. In other words, we took the derivative of that, so we've still got a t minus 6 that needs to go there.
Oh, yeah, sorry. Yeah.
There was a 1 here that I didn't write. So it was u times v prime plus u prime times v times the derivative of that inside, which is 1, like I said. So anyway, there is our velocity function. Acceleration is what?
Just the derivative of that.
Okay, so it's the derivative of velocity.
So it would be 3t minus 2 plus
squared.
Yeah.
Okay.
Plus 6t. I mean, no, 3t minus 2 squared. Times 1 plus 6t minus 2 t minus 6.
Good. Now, well, I can add some of that. That plus that is 6 of them. So I can simplify that a little bit, and you do want to simplify these if you can simplify them. So that's 6 of t minus 2 squareds. I actually could multiply these all together and combine t squareds and end up with one gigantic quadratic. And I'm tempted to do that, other than the fact that we're running out of time and I want to get to the rest of these because the rest of these questions are important. So for the moment, let's just write it like this. But you see where I could definitely simplify this. If I multiply the t minus 2 times the t minus 6, I'm going to have a quadratic. I'm going to have a quadratic if I square that, combine all the like terms of a quadratic, and you end up with one single final quadratic that are going to have 12t squared in it. But that's not significant. Let's see if we can work with it in this form. That's not the form you'd pick from a multiple choice. They would definitely simplify it, but we're going to pass that step. Find the value of t when the particle is moving and the acceleration is 0. Well, now I'm going to have to make that a quadratic. Not as hard as it looks here.
Oh, okay.
It's t squared minus 4t plus 4 plus, I multiply those two together, I'm going to get t squared minus 8t plus 12. Now if I combine that all together up top here, I get 6t squared minus 24t plus 24 plus 6t squared minus 48t plus 72. And now I've got to simplify that. Well, I got 12t squared. I got minus 24t minus 48t, that's minus 72t. And I got a plus 72 and a plus 24, that's plus 96. There's my acceleration function. And they're asking me where that is equal to 0. Hopefully I haven't made a math there. I'm not going to be able to track it down. But notice this is going to actually be pretty easy to solve. If I set that equal to 0, first thing I'm going to do is divide everything by 12. So now I have t squared minus 6t plus
8.
Thank you. My mind went blank for a moment. Equals 0. And that means that we have t plus 4 times t plus, minus. T minus 4, t minus 2 equals 0. The two times where acceleration is 0 are at time 2 seconds and at time 4 seconds. Okay? Now, not sure why they put, and the particle is moving. I guess if we put in these two times back into this velocity function, we will see that the velocity is not 0. Although, right offhand, okay, that's why they put it in there. Notice that if we put in 2 or 4 into the velocity function, this term goes to 0, this term goes to 0. So the velocity is 0 at time of 2 seconds. So that's not one of the points they're looking for. They want the value of t when the particle is moving and the acceleration is 0. Well, that only comes when t is equal to 4. Notice that if I plug in 4, nothing goes to 0. So we have a positive velocity, or at least we have a velocity that's not 0 when we plug in t of 4. So that's our only answer to part B, is t of 4. God, these questions are brutal. I'm not sure I've ever seen a question like that.
Really?
You just say, yeah, what 2 points is the acceleration 0? And you give them 2 and 4. But to say that the velocity has to be non-zero means you have to plug in those 2 points into your velocity function to make sure that the velocity is not 0.
Jeez.
I know. Okay, so when is the particle moving to the right? When the velocity is what?
Positive.
Correct. Particle's moving to the left when the velocity is negative. So we have to take this velocity function and set it greater than 0. That'll tell us when it's moving to the right. And set it less than 0, and they don't even ask when it's moving to the left. So we won't worry about that. But we have to solve this equation for being greater than 0. Let me look at that equation for a moment. That's a cubic. But I can factor out a t minus 2 squared, leaving behind a t minus 2 plus 3 times t minus 6. So that's what has to be greater than 0. They're not expecting you to solve these by hand, are they?
I think so. It's quite difficult.
Well, I know how to do this. Let's do it. If we have the time, we got 5 minutes. Here, I may not get to the last part, but we can certainly do this. You can use a line chart. Let me erase all of this. After all that hard work, we're only going to have time to solve this. So, when you have the product of two things, a times b is greater than 0, here's the way you solve it. You figure out your critical points. What makes that 0? What makes that 0? Either one are your critical points. Well, we have one critical point at t equals 2. We have another critical point. Is there anything that makes t minus 2 plus 3t minus 18 equal to 0? What is that? That is 4t minus 20 equals 0. Yeah, when t equals 5. That's another critical point. Okay? Now, let me show you what to do with those critical points. It's called a line chart. You've dealt with it in the past before. You put your critical points on there.
2 and 5.
You don't put 0 on there, because there's only 3 things that can happen. Anything to the left of 2 is either going to be plus or minus. anything between 2 and 5 is either going to be plus or minus, and anything to the right of 5 is going to be plus or minus.
And you just plug it into the equation to figure it out?
Let's plug in 0 for t. That becomes plus. That becomes a minus 2 minus an 18. So that's a positive times a negative. That's negative in that range. Plug in a number between 2 and 5. Let's try 3. Well, that's positive. That's a plus 1. This is still a big negative number, so this is still negative over there. Positive times negative is negative. That's not greater than 0 either. Now let's go to the right of 5. Let's pick 6. That's still positive. That's 4. That's 0. So now we have positive times positive is a positive, and there's your solution. T of greater than 5 is where the particle is moving to the right.
Okay. Makes sense to me.
All right. When is the velocity of the particle decreasing? Well, there's the other half of it. It's this area.
5. Okay.
Decreasing when it's less than 5. When is the speed of the particle increasing? I gotta go. This is a fairly long subject to get a handle on, speed. Speed is not the same as acceleration. Speed is the absolute value of acceleration. You can have something that's accelerating and increasing in speed, but you can also have something decelerating that's increasing in speed. If it's going to the left and speeding up, that's negative acceleration, but it's increasing speed. So it's very confusing to get those two straight. I can straighten it out for you, but not in 30 seconds. So we'll have to put that off till next time. But let's come back to this problem next time. We want to get a handle on that last part. That last part is on every test where they ask you about speed, not acceleration. Jake, I will talk to you next time.
Cool. Well, thank you.